Hey guys, Mr. Milton here. Today we're going to talk about solving word problems using systems of equations. At the end of this video, you should be able to write a system of equations from a word problem, and you should be able to solve word problems involving systems. Alright, so as we solve word problems, here's what we're going to do. We're going to make sure that we define our variables. Define, that means we know what x stands for, what y stands for, whatever variables we use. We don't have to use x and y, but we're going to know what they mean so that we can make sense of them as we solve our problems. Okay, we're going to use what we know to write two equations. And then we're going to solve the system using either substitution or elimination. So, let's read through the first problem. It says the Colts have scored 225 points this season so far. The number of touchdowns is 3 more than double the number of field goals. Assume that they have only scored on touchdowns 7 points and field goals 3 points. How many touchdowns have the Colts scored and how many field goals? Okay, so things we want to find out. We're going to find out the number of touchdowns. Okay, how many touchdowns? I want to say that the number of touchdowns is T, and then the number of field goals is F. Okay, so that's me defining my variables, just that we know what that stands for. Alright, so the thing that I go back to help me with these story problems is just to know they have to give me enough information to solve it. Okay, if they don't give me enough information to solve it, then I have to then I can't do it. Okay, so let's look at an equation, or let's look at the information to see what equations are in this problem. Okay, the first thing it says the number of touchdowns is for us means equals 3 more than double the number of field goals. 3 more than double the number of field goals. So touchdowns is 3 more than double the number of field goals plus 3. So this is a comparison of touchdowns to field goals. Touchdowns is 3 more than double the number of field goals. Alright. Also it says the Colts have scored 225 points so far this season. Okay, and what we're doing, we're saying each touchdown is 7 points and the field goals are 3 points. So when we add the number of touchdowns we scored, so number of touchdowns times 7, because each touchdown is worth 7 points. We add that to the number of field goals we scored, which each field goal is worth 3 points, so 3 times the number of field goals, we should get 225. Okay, so all this information is from the problem. We've defined our variables so that even without this problem now, we should be able to say, okay, touchdowns is 2 times the field goals plus 3. Okay? 7 times the number of touchdowns plus 3 times the number of field goals should equal 225 points. Okay? So we don't have to read this problem anymore to know what it's saying. Okay, so now we have this set up, the system set up, and so we have to choose how to solve it. Okay, we're going to solve by substitution. And the reason that we're going to solve by substitution is we have a variable by itself. We already have a variable by itself. So in this case, we have t by itself in the first equation. And with substitution, remember, we wanted to get a variable by itself. So since they started us off this way, probably the best way to go. So what I'm going to do is in this second equation, instead of writing t, I'm going to rewrite the second equation as 7. And since t is the same as 2f plus 3 plus 3f equals 225. Okay, and so now I'm going to just solve this for f. So I have 14f plus 21 plus 3f equals 225. 17f plus 21 equals 225. Subtract 21 from both sides. 17F equals 204. And 204, oops, that's not the right number. 204 divided by 17 is 12. So F equals 12. Okay, so we should have scored 12 field goals. Okay, and so since I know the number of field goals, and this is why it's important for me to use variables or something that I know what it is, because I wouldn't want to get to this point and say 12 touchdowns, because I did get 12, but I know that F stands for field goals. Okay, so I have F is 12 field goals, and what I'm going to do now is I'm going to plug that number into my top equation. Instead of using 2, I'm going to use 12 plus 3. So 2 times 12 is 24, plus 3, I get 27. So the Colts have scored 27 touchdowns and 12 field goals. Okay, if you wanted to, you could plug that back into this bottom equation to make sure that it works out. Because it should work out for both. Alright, let's move on to the next system. It says Tyler and Stephanie bought some DVDs and Blu-rays during the Black Friday sale this past Friday. Tyler bought 12 DVDs and 5 Blu-rays and spent $60.88. While Stephanie bought 4 DVDs and 7 Blu-rays and spent $46.96, both before tax. What was the average price for a DVD and for a Blu-ray? Okay, so important here that we're talking about average price, because maybe they bought one that was $10 and one that was $2, and we don't want to get into that for this problem. But we will be able to find the average. And so what I'm going to use here is I'm just going to say, hey, DVDs, that's going to be D. Blu-rays, that's going to be B. Okay. And so now I'm defining my variables. I can use those. And I'm just going to break this down into the two people who bought it. We have Tyler's trip. And in Tyler's trip, he bought 12 DVDs. He bought 5 Blu-rays. And that cost him $60.88. Okay. In Stephanie's trip, she brought 4 DVDs and 7 Blu-rays, and that cost her $46.96. Okay. So now we have a system solved, and what we see here is in the last time we had a variable by itself. Okay, and so that really said, hey, substitution is probably the best way to go. Here we don't have a variable by itself, and as we look at it, it's not really a variable that we can say, oh, this is going to be really easy to get by itself either. And we also notice that the variables are on the same side, so this is pretty much set up for us to solve using elimination. Okay, both of these are in standard form. If you think about it, as both variables be on the same side. None of the variables seem like they're really close to being by themselves. Okay, so as we do this for standard form, I'm going to try to find which variable is going to be the easiest to eliminate. And actually, for this case, I can see 12 and 4, 5 and 7, that 12 and 4 can both be 12. And I can make this 12 by multiplying this bottom equation by -3. Okay, I'm going to multiply the bottom equation by -3. So I'm going to rewrite that out here. Top equation stays the same, 12D plus 5B equals 6088. Bottom equation, I'm multiplying everything by -3. So I'll get -12D minus 21B equals, and then I have to do this on a calculator, 4996 times 3. So -149.88. All right, and so now, set up for elimination, I'm going to combine these here. So I get 12D minus 12D, 0, goes away. 5B minus 21B is -16B. And then I have to do this on the calculator as well. 6088 minus 149.88, and that gives us -89. Okay, So I have negative 16b equals negative 89. I can find out what b is by dividing both by negative 16. I'll do that again. 89 divided by 16. Oh. Did I type the wrong number in? I believe I did. Hold on a second, guys. Sorry. Okay, so this answer doesn't make sense to me, so I say I might have messed up somewhere, which I'm going to go back and make sure I didn't. So I did 4696. Oops. 4696 times 3, and that gave me 140.88, not 149.88. Okay, which changes this to $80. Okay. All right, and then 80 divided by 16 is 5. All right, there we go. See? And that's why I wanted to find our variables, because I said, wait a second, that is way too many decimals for this to be a money problem. I might have messed up. Okay, and so now I find out that Blu-rays, the average cost of her Blu-rays were $5. Well, not her Blu-rays, Stephanie and Tyler's Blu-rays were $5 for the day. Okay, and so now that I know that that's $5, I can plug that into one of the equations. I'll plug it into the bottom equation, why not? So I have 4D plus 7, I'm going to type 5 for the Blu-rays, equals 4696. So 4D plus 35 equals 4696. Okay, 4696 minus 35. Give me 1196. So 4D equals 1196. Divide both of them sides by 4. And we find the DVDs cost $2.99. Average cost for the DVDs is $2.99. The average cost for the Blu-rays were $5. All right. So there we have it. All right. Flipping over to the back side. Okay, I have 37 coins in my pocket. All quarters and nickels, totaling $6.05. How many of each coin do I have? All right, so even though this seems like a pretty short story problem, there's enough information for us to write a system of equations. Okay, here I said I have 37 coins in my pocket. They're all quarters and nickels. Right there, that's enough for me to write an equation. The number of quarters I have, Q, plus the number of nickels I have, N, equals 37. Okay, so that's one amount talking about money. All right, how many coins I have. Now we got to talk about the value of the money. So I said that they're worth $6.05. So here's my trick before we get started any further. I guess before we get going any further. When we're talking about money, if it's less than $1, if everything's under $1, I just like to change it to cents. That way I don't have to worry about decimals. Okay, so I'm just going to talk in cents. Okay, now each quarter is worth 25 cents. So I have 25 cents per quarter. I have 5 cents per nickel. Equals, and I know this says $6.05, I'm going to say 605 cents. Okay, so nice that the dollar is set up that way that it's in the hundreds, so we can do that pretty easily. But this way I get to avoid any kind of mistakes that'll happen. I will let you guys know that the biggest mistake that happens here is that as guys are writing or students are writing about nickels, what they'll do is they'll say 0.5 in if they use decimals. Okay, and this is not right, because remember that 0.5 would be half a dollar. Half a dollar is 50 cents. So if you're talking about a nickel, you have to say 0.05 in. Okay, but we kind of can avoid that by just saying, hey, a nickel's worth 5 cents. A quarter's worth 25 cents. This is 605 cents. Okay. All right, so going on from there, can't always do that, but it's nice when you can. All right, so going on from there, we're trying to solve for the number of quarters and nickels, and what we can do is, well, eliminate. We have both variables on the same side, so we can eliminate. You also, if you wanted to, you could subtract n from both sides or q from both sides and use substitution. So either one, this is really a situation where you can say, hey, I could get substitution. I like substitution better. Do substitution. Or if you say, hey, I like elimination better, do elimination. I like elimination better. So that's what I'm going to do. And I can see that I'm going to be able to eliminate these n's pretty quickly. I'm going to multiply this bottom equation by -5. Okay, so I have 25q plus 5n equals 605. I'm going to multiply the bottom equation by -5, so I have -5q minus 5n equals -185. Make sure I did that right. 37 times 5. Okay. So -185. And now I'll add these together. End up with 20q. The n's cancel out. And then I'll get 605 minus 185. And that's 420. So 420 divided by 20 gives me 21. So I have 21 quarters. Okay, which makes this first piece of information help me out a lot. If I have 21 quarters, that must mean I have 16 nickels. Okay, and you could just make sure that works out for you. If you wanted to, you could say, okay, 21 times 25, that's 525. 16 times 5, that's 80. 80 plus 525 gives you that 605. So basically you plug that back into the top equation. Okay, so there we have it. All right. Example 4 says Julie has $554 in her savings account. She deposits $12 per week into this account. Julie has a checking account with $770 from which she withdraws $15 per week. At this rate, how many weeks until her two accounts have the same amount in them? Okay, pause this, try to do it on your own. Okay, try to do this problem on your own. Pause it and try it right now. I'm going to go through this really quickly, show how it should be. Your savings, A equals, she has $554 already to start. She's adding $12 per week. Her checkings, the amount in her checkings, she had $770, and she's subtracting or withdrawing $15 per week. So this should be the system that you're set up with. Both equations have a variable by himself, so we should probably use substitution. And in the second equation, I'm just going to say 554 plus 12w equals 770 minus 15w. I'll get 27w. 770 minus 554 is 216 equals 216. W equals 8. So how many weeks until they have the same amount? 8 weeks. Alright, hopefully you tried that on your own, got that answer, and are satisfied. Alright, last example. It says, suppose you're trying to decide whether to buy or rent ski equipment. You find out that it costs $60 per day to rent ski equipment and buy a lift ticket. You can buy ski equipment for $400, and a lift ticket alone costs $20 per day. If you plan on going skiing for 8 days this winter, should you buy the equipment? Okay, so here we go. If you rented the equipment, because they gave you the two pieces of information, the amount that you would pay is $60 per day. If you bought the equipment, the amount that you would pay be $400 for the equipment, and you add to that the lift ticket, which you have to buy separately now, for $20. Alright, so we can solve this equation if we wanted to and say, okay, when will it be the same? When will the cost, when will the amount of rent and the amount that you buy be the same? And so we say, okay, 60D, because this is set up for substitution just as our last problem was, 60D equals 400 plus 20D. Okay, substituting 60D for A. Okay, and then we get 40D equals 400. And then we solve and get D equals 10. So at 10 days, they'd be the same. Okay. So if we rented 8 days, if we rented for 8 days, this will cost 60 times 8, which is $480. If we bought and spent 8 days, we'd have 160 plus 400, which would be 560. Okay, so should we buy the equipment? The answer is no. We shouldn't buy it. We should rent it if we're only going to be there for 8 days. When would it be better to buy the equipment? If you had 10 days or more of skiing. Okay, because at 10 days, if you're going to spend the $600, you might as well have the equipment to take with you. But after or before that, then you get to save some money by not buying it. All right, so there you have it. There's word problems. Solve these systems. See you.